Hey, what's up, pre-calculus? We're going to go over the ideas behind x and y intercepts of functions, what they look like, and how to find them. So let's get into this. An x-intercept of a graph occurs when y equals 0, and the y-intercept of a graph occurs where x equals 0. And you can see that right down here on the graph below. We have three x-intercepts. You could label them, and you can see that the y value for each of those is 0. And we have one y-intercept down here. Clearly you can see that the x value of that is 0. A function graph can have 0, 1, or more x-intercepts, but at most just one y-intercept. And remember, if we're calling it a function, it passes something called the vertical line test. So if there was maybe another y-intercept somewhere else along this graph, that would certainly fail the vertical line test. And x-intercepts of the graph of a function are also called the zeros of a function. And that's the point of what we're going to look at here today. So over here we do have the graph shown of x cubed plus 5x squared minus 4x minus 20. You can see a nice cubic shape, 3 x-intercepts. And if we want to look for the y-intercept right down here, negative 20. When we want to state the zeros of this function, we will note that the three x values that cause a y value of 0, negative 5, x equals negative 2, and x equals positive 2. These are the three zeros of the function. Let's calculate f of 0 using our algebra skills. So we will substitute 0 in where the x goes. And this is a relatively simple computation. We could probably do this in our head, but I will show the workout for that. So we zero out all the x's, and when we tally this up, 0, 0, 0, and minus 20, we do get the numerical value here. That, of course, matches the y value down here. And now let's solve that equation. And when we set the function equal to 0, we should find the values where we have x-intercepts. And again, we already have the connection to the graph here. We anticipate three separate answers of negative 5, negative 2, and 2. Let's just get into how to make that happen. So we have four terms here. Best way to go through this is to try to factor by grouping. I see from the first two terms I have a GCF of x squared. I'll pull that out. And from the second two terms I have a GCF here of negative 4. So I'll factor that out as well. I can see I've now caused a GCF of x plus 5 to pop up. So I can factor that out, and that leaves me with x squared minus 4. All right, this one here can break down a little bit more. We've got difference of squares, and we can break it on down to conjugate pairs. Just come up with two binomials that multiply out to x squared minus 4. X plus 2 and x minus 2 should get the job done. All right, let's set each factor here equal to 0. Once again, this could be maybe a mental step for a lot of you. If you do want to write it out, that's fine too. But we would now algebraically come up with the values x equals negative 5, x equals negative 2, and x equals positive 2. And we have found the values of the three zeros using algebra. And of course, they do match the values from the graph. We're going to handle two more problems here. We're just going to do these algebraically. We're going to find the x and the y intercepts. So let's do the y-intercept first. That's usually going to be a little bit easier. And I'll substitute 0 where the x is. Again, fairly simple computation there, and we get negative 15. Let's find the x-intercepts next. We will set the function equal to 0. And now we've got to try a way to factor or unfoil this. Now, whatever method you learned in Algebra 1 and 2, if you like it, keep it. But I tend to just try to figure out what two binomials FOIL out or multiply to the original. Little shortcut here or trick, maybe if you can get good at it, Notice the first items in the parentheses have to multiply to 2x squared, and the last value in each set of parentheses must multiply out to negative 15. The only thing we need to figure out is which factor pairs and which position they're in. And really, I've just kind of made up a couple guesses here, and I'm trying to generate which one has the middle term of 7x. Now, one of these comes pretty close. This guy right here, pretty close. Foil it out, 2x squared, we'd get minus 10x plus 3x minus 15. That would give me a middle term of negative 7x. I want positive 7x. So I've got the right values with the wrong sign. Okay, so maybe we can try 2x minus 3x plus 5. And again, let's just check this out, that it foils back to the original. We'd get 2x squared plus 10x minus 3x, that makes 7x, and then minus 15. So we have correctly broken this down. We may now set each factor equal to 0 and solve for the zeros of the function. And we do get 2 of them, and that should make a certain amount of sense. We do have a quadratic function here, and we know that will form the graph of a parabola, and it's very believable we have a parabola that would cross the x-axis at 2 locations, -5 and +3/2. Okay, let's just round this out. One more example, finding x and y intercepts of functions. And if we find the y-intercept for the function here in number 3, we would do the same thing there. And we input a value of 0 for all of the x. And tallying that up, we get 0 plus 0 plus 0. Looks like a whole lot of 0 to me. And let's just get our x-intercepts going now. So I'm going to set my function equal to 0. I do want to work this out through factoring. I do see the GCF here is x. I'm actually going to factor out a negative x from this. And this one shouldn't be too bad to try to keep factoring or unfoiling. Let's just make a good reasonable guess. The first 2 terms must be x to multiply out to x squared. And we need to come up with some values that multiply to 18, negative 18 and combine to +3. I do think x plus 6, x minus 3 makes that happen for us. And if we set each factor equal to 0, we will get 3 values here, 3 zeros of the function, 1 at 0, 1 at -6, and 1 at +3. And that should not be so much of a surprise. We have a function here, it's called a cubic function. Highest exponent is 3, and that corresponds to how we have found 3 zeros of that function. And even going back to the parabola here, degree is 2, and we found 2 zeros of the function. So that connection is still alive and well from what you learned in previous math courses. Okay, gang, that's it for now. Ta-ta!